Hi, today we're going to be learning about reflections, which is part of the transformation geometry section. Before we start, I want to just quickly remind you that when we are transforming points and shapes, the image of point A after a transformation is called A prime. Okay, so anytime you have a point that has been transformed, remember we can have different kinds of transformations. We've already learned about translation transformations. Today we're going to be learning about reflections, and then we're also going to still learn about rotations and enlargements and reductions. So anytime a point undergoes a transformation, we call it A prime. The image of that point after the transformation is called A prime. Okay, so now let's go on to reflecting points on the Cartesian plane. We can reflect or flip a point over a certain line, which we call the line of reflection. And when we do this, we end up with a mirror image of that point. There are different possible lines of reflection that we can use, including, but not limited to, the x-axis, the y-axis, the line y equals x, and the line y equals negative x. This year we are going to be focusing on just the first two, the x-axis and the y-axis, when reflecting a point or a shape across the x-axis or the y-axis. When reflecting a point, the reflected point must be located on the opposite side of the line of reflection at an equal distance. So now let's have a look at an example where I'll show you how to actually do this. Okay, so in this example, we've got the point B is the point 3, 6, and we need to determine and write down the coordinates of B prime, which is the image of the point B after it's been reflected in the x-axis. Okay, so first, let's see where the point B is. Okay, so the point 3, 6 is over here, so this is going to be the point B over there. Then we also need to know what line is the line of reflection. So in this case, we're reflecting in the x-axis. That means that the x-axis is going to be a line of reflection. So this is our line of reflection over here. Now remember we said over here that when reflecting a point, the reflected point must be located on the opposite side of the line of reflection at an equal distance. Okay, so now back over here, if this is the line of reflection, then B prime has to be on the opposite side of this line, which means it has to be, if B is above the line, B prime is going to be below the line, and it also has to be at an equal distance from that line of reflection. So let's see what the distance is from the line of reflection to B at the moment. So if I take this and I work that out, I'll see that that is 6 units, that distance from the x-axis to B. That means that B prime must be on the opposite side of the x-axis, also 6 units away from the x-axis. So that is where the reflection of B is going to be, and that's what we call the point B prime. The coordinates of the point B prime will be 3, minus 6. So this is the point B prime over here, the coordinates, 3, negative 6. Okay, so now you're going to do a few of these for yourself. In this activity, you've got 4 different points that you are going to need to reflect in either the x-axis or the y-axis. You'll see some of them say about the x-axis or across the y-axis or in or over. It doesn't matter. All of them are reflection transformations. Okay, so you're going to be doing the same thing for all of them. It doesn't matter if they use slightly different wording. Okay, so I'm going to give you 2 minutes to work out the coordinates of each of the images of each of these points after they've been reflected. Okay, so let's go through each of those examples. So the first one we have over here, the point A is the point minus 4, 3, so that's over there. Then we were reflecting it about the x-axis, which is over here. So we need to see the distance from A to the x-axis is 3 units, which means that the point A prime is going to be on the opposite side of the x-axis, also 3 units away. So it's going to be over here. So this is the point A prime over here. And it has the coordinates -4, -3. Right, then the next one, the point B is 2 minus 3, so that is over here. We are now reflecting across the y-axis. So I want to know the distance from B to the y-axis. So that is 1, 2 units. So I'm going to be going 2 units on the other side of the y-axis to here. So this is going to be where our reflected point is. And that is the point B prime. And it has the coordinates -2, -3. Okay, then the next one, the point C, which is 0, 0, that's on the origin over here. Now, when you're reflecting a point which is on the line of reflection, so in this case, we're reflecting it in the y-axis. So the y-axis over here. Now, the point C is on the y-axis already. So that means that the distance from the y-axis to point C is 0. So when we have the reflection, it's also going to be 0. So the point C prime is actually exactly the same as the point C because the point C was already on the line of reflection. So when that happens, then the point C and the point C prime are the same as each other. So in this case, the point C prime has the coordinates 0, 0, just like the point C because it was on the line of reflection. Okay, then we've got the point D, which is the coordinates 2 minus 1, so that's going to be over here. And now we're reflecting it over the x-axis, which is over here. So this has got a distance of 1 unit. So we're going to be going 1 unit on the opposite side of the x-axis is going to get us over here. So that's going to be the reflected point, which is D prime. And it has got the coordinates 2, 1. Okay, now let's go and have a look at reflecting shapes on the Cartesian plane. When you reflect shapes on the Cartesian plane, what happens is you take each point in that shape and you apply the same reflection to each point, and then that will cause the whole shape to be reflected. Okay, so let's have a look at our first example over here. Write down the coordinates of A prime, B prime, and C prime if triangle ABC with vertices A, which is -2, 6, B, which is -3, 4, and C with coordinates 2, 3, is reflected about the x-axis. Okay, so first let's have a look at where this triangle is. We're going to first plot those points and get our triangle. So we've got this triangle over here where the point A is -2, 6, the point B is -3, 4, and the point C is 2, 3. And this has then all the points have been joined together to form a triangle. Now we are going to be reflecting about the x-axis, which means that our line of reflection is the x-axis over here. So we're going to take each of the points A, B, and C, and we are going to apply the same reflection. We're going to reflect each of the points about the x-axis. So we're going to start with point A. Okay, so let's have a look at the distance from A to the x-axis. That is a distance of 6 units, which means that when we reflect it about the x-axis, we're going to have the reflection of A on the opposite side of the x-axis the same distance away. So it's also going to be 6 units, and it's going to be, this is 6, then we go 6 down over here. That's going to give us a point over here, which is going to be our reflection of A. That's the image of A, or A prime. Then we've got point B. So point B is over here. The distance from B to the x-axis is 4 units. So the reflection of B is going to be on the opposite side of the x-axis, also 4 units away from the x-axis. So that's going to get us a point over here. So that is our reflection, and that is B prime. Then for the point C over here, this distance is 3 units from C to the x-axis. So again, the reflection of the point C is going to be on the opposite side of the x-axis, also 3 units away. So it's going to be over here, like that. And that is going to be our point C prime. Okay, so now we can go and join those 3 up to get our triangles. Now you can see that this whole triangle is a mirror image of that triangle, where this line is like our mirror line, or our line of reflection. Okay, and then the coordinates, because we were asked to write down the coordinates of A prime, B prime, and C prime. So the coordinates of A prime are going to be -2, -6. The coordinates of B prime will be -3, -4. And the coordinates of C prime will be 2, -3. like that. Okay, so now you're going to do one for yourself. In this example, you have got to draw triangle PQR with vertices P, -2, 1, Q, 0, 5, and R, 6, 0 on the Cartesian plane. Then you need to draw the image of that triangle after it has been reflected in the y-axis, and then you need to write down the coordinates of P prime, Q prime, and R prime. I'm going to give you 2 minutes to work on this example. Okay, so let's go through that and see what you should have got. So first of all, you have to draw the triangle PQR using the coordinates that you were given. So when you draw the triangle, it should look like this, with point P over here at -2, 1, point Q on the y-axis at 5, and point R on the x-axis at 6. Okay, then you have to draw the image of PQR after it is reflected in the y-axis. Okay, so first you had to work out where each point was going to be after it was reflected. The point P would end up over here after the reflection about the y-axis. So point P prime will be over here. Point Q, when it's reflected and you get Q prime, is going to be exactly the same as point Q because it's on the line of reflection. So point Q prime is going to stay the same as point Q. And then point R prime is going to be over here on -6, also on the x-axis. So that's what your triangle should look like after it has been reflected. Okay, now to get your coordinates. The coordinates of P prime are 2, 1, Q prime 0, 5, and R prime is the point -6, 0. Okay, so that's what you should have got for that example. Now let's have a look at area and perimeter when a shape is reflected. First of all, rectangle ABCD with vertices A, -7, 3, B, -7, -2, C, -4, -2, and D, -4, 3 is reflected in the y-axis. Calculate the perimeter of ABCD, calculate the perimeter of the image of ABCD, calculate the area of ABCD, and calculate the area of the image of ABCD after the reflection. Okay, so first of all, we need to find out where ABCD is on our Cartesian plane. So if you plot the points A, B, C, and D, you should end up with a rectangle that looks like this, where A is the point -7, 3, B is the point -7, -2, C is the point -4, -2, and D is the point -4, 3. So that's what your rectangle ABCD should look like. Then you have to reflect this about the y-axis. So when you're reflected about the y-axis, you're going to end up with a rectangle that's going to look like this. Now let's go and have a look at the perimeter and the area of these two rectangles. So first of all, the perimeter of rectangle ABCD. To work out the perimeter, we're going to use our formula 2 lengths plus 2 breadths. The length of our rectangle is 5 units and the breadth is 3 units. So that's going to be 2 times 5 plus 2 times 3, which gives us 10 plus 6, giving us a perimeter of 16 units. Then let's have a look at the perimeter of the reflected rectangle. So the perimeter of the image of ABCD is also 2 lengths plus 2 breadths. The length is also 5 and the breadth is also 3. So it's going to be 2 times 5 plus 2 times 3, giving us 10 plus 6, which is 16 units. So the perimeter of these two rectangles is the same. Now let's have a look at the area. The area is worked out by saying length times breadth. So the area of ABCD is length times breadth. We're going to have 5 multiplied by 3, which gives us an area of 15 square units. Then if we look at the area of the image of ABCD after the reflection, it's also length times breadth. The area is also worked out by saying 5 times 3 because the length is also 5, the breadth is also 3, and that gives us an area of 15 square units, the same as we had for ABCD. So when you reflect a shape, the perimeter remains the same and the area remains the same because these two shapes are actually congruent to each other. Okay, they're exactly the same as the reflection is exactly the same as the original shape. It's just in a slightly different place and a slightly different orientation. Okay, so now let's go and have a look at the rule that we can say over here. When a shape is reflected, the size and shape do not change. The image is congruent to the original shape. That means that they are exactly the same shape as each other, just in a different position or orientation. Okay, this means that the area and perimeter of the image are the same as the area and perimeter of the original figure. Now let's have a look at the rules for reflections. Now we know how to work out the coordinates of a point after it's been reflected by drawing it and so on, but it helps to also have rules that we can use that do not require drawing the points on the Cartesian plane. So let's have a look at how we can work this out without having to do any actual drawing. Okay, so if point T is reflected in the x-axis, then what happens is if you have T with coordinates x and y, whatever those two coordinates might be, so x could be 2, y could be 5, whatever. Let's go and have a look at some examples that we did over here. Okay, so when we did this activity, this point was reflected about the x-axis. Let's have a look at what happened to the coordinates. So the original point was -4, 3, and after the reflection, the point was -4, -3. So the -4 didn't change. The x value, when we reflected about the x-axis, did not change. But the y value changed from 3 to -3. In this case over here, we're also reflecting over the x-axis. And again, the x value stayed the same. It didn't change, but the y value went from -1 to +1. Here it went from +3 to -3. So when you're reflecting about the x-axis, what happens is the x value is going to stay the same and the y value is going to just change sign. And the way that we change sign is by multiplying by -1. So this is going to become x, staying x, and then y changing to -y. Or if y was already negative, it changes to positive when we multiply it by -1. Okay, so in other words, the y value changes sign and the x value stays the same. Okay, so that's what happens when you reflect across the x-axis. Then let's have a look at what happens when you reflect in the y-axis. Okay, so just like when we're reflecting in the x-axis, we're starting off with point T, which has coordinates x, y. Now let's have a look at some examples that we did over here. So when we had the point B, 2 - 3, and we reflected across the y-axis, we found out that the coordinates after the reflection were -2, -3. So if you look over here, when we reflected across the y-axis, the y value stayed the same and the x value changed sign. Now in this one it wasn't so easy to see because the point C was on the y-axis. Okay, so you can't see anything changing sign, but if it had been different coordinates, the same thing would have happened. Okay, so let's have a look at our rule for this one. So if we are reflecting point T in the y-axis, then T starts with the coordinates x, y, is going to end up with the coordinates -x, y, where the y value stays the same and the x value changes sign. Okay, so when we're reflecting across the x-axis, the x value stays the same and the y value changes sign. If we're reflecting across the y-axis, the y value stays the same and the x value changes sign. And that is how you reflect points or shapes on the Cartesian plane. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.